Today we're going to look at section 6.1, classifying quadrilaterals. And so the first page on this recording is just showing you each of these different quadrilaterals and what their special properties are. So the first one, a parallelogram, is a quadrilateral with both pairs of opposite sides parallel. And I've drawn an example here. So the opposite sides are parallel. A rhombus is a parallelogram that has 4 congruent sides here. So that means a rhombus, since it is a parallelogram, it means it has equal sides, but it also means that the opposite sides are parallel because it's a special case of a parallelogram. A rectangle is also a special case of a parallelogram, and in this case it has 4 right angles. So opposite sides are still parallel because it's a parallelogram, but now there are 4 right angles where the corners are. And then finally, a square is a parallelogram also. It's also a special case of a rectangle that has 4 congruent sides and 4 right angles. Now notice the rectangle and the square still have opposite sides that are parallel because it's a parallelogram. Okay, a kite is a quadrilateral with 2 pairs of adjacent sides that are congruent and no opposite sides congruent. So this is a picture of a kite. Here, the adjacent sides means they're right next to each other. They're not across from each other. So on the right side of it, I have 2 hash marks through the congruent sides, and then on the top, there are one hash mark each. So it's different because it's not the opposite sides that are congruent, but the adjacent ones. And then another one is a trapezoid. So it has 1 pair of parallel sides, and so here's an example of a trapezoid where the top and bottom are parallel. And in this case, it's a special trapezoid, an isosceles trapezoid, because the 2 legs that aren't the parallel sides are congruent. Okay, I really like this diagram that your book had, and it kind of helps you put things into perspective of what different types of quadrilaterals there are. So first I have at the very top quadrilateral, and from that I'm branching off to the right. I'm sorry, to the left. And on this side there's a kite. It has no pairs of parallel sides, but I did mark the congruent sides on the kite. Okay, in the middle here I have figures that have 1 pair of parallel sides. That would be a trapezoid. And a special case of a trapezoid is an isosceles trapezoid. So in a regular trapezoid, the legs, or the bases, are the sides that are congruent. That's what we call those, the bases. And so the 2 sides that are not parallel, I'm sorry, did I say congruent? The 2 parallel sides of the trapezoid are the bases. The ones that are not parallel are called the legs. So a special case of a trapezoid would be the isosceles trapezoid, where it has congruent legs, but the regular trapezoid doesn't have to have that. And then finally, over here on the right, I have figures that have 2 pairs of parallel sides. So the most general figure is the parallelogram, and then underneath that are special cases. So the rectangle is a special case of a parallelogram, the rhombus is a special case, and then the square is a special case of a rhombus and a rectangle. So sometimes they'll ask us for the most precise name for a quadrilateral based on what we know. And what they're asking is, try to go as far down the diagram as you can. So if I had a parallelogram that was also a rhombus that was also a square, the most precise name would be the square, because it gives me more information than the others do. Okay, so quick check 1 gives us a picture of this quadrilateral XYZW. And they're asking me to classify it with as many terms as I can based on appearance. Okay, so I know that, and this is based on appearance, which means it doesn't have to have everything marked like the parallel sides. They did tell me that the sides are all the same length. So to me, this looks like it would be a rhombus. My pen's not working. I don't know what's going on with my pen right now. Let's try that again. right, that's a pretty specific name. We can't say it's a square because there aren't right angles. But since the rhombus is here, they asked me to name it with as many terms as I can. So if it's a rhombus, it's also a parallelogram. That's a little more general. Okay, and then if I go further up, I can also say that it's a quadrilateral. I don't know what's wrong with my pen today. Okay, so some of your problems are just going to be classifying based on what it looks like to you and as much information as they give you. Now, there are other problems that are going to give us coordinates for a quadrilateral, and it's going to ask us then to determine the most precise name. So that means we're going to go down as far down that chart as we can and be the most precise that we can. So I was given the figure that is drawn on the left of the graph, the quadrilateral LMNP, and I was given their coordinates for each point. And so the first thing I want to do is check and see, is this a parallelogram? So that means that opposite sides would need to be parallel. I could also check for whether or not any of these are perpendicular or at a right angle. By both of these things, I can calculate slope and determine. So I went through and I calculated the slope of LM. So that's the line here. And so I'm just subtracting y values on top and x values on the bottom. So 3 minus 2 over 3 minus 1, and it gives me 1/2. Then I calculated the slope of NP, which is opposite LM. Okay, when I calculated it using those points, I also got 1/2. So since those have the same slope, I know that LM is parallel to NP. Then I checked the other two sides. So I checked MN and LP. MN turned out to be negative 1/2 when I did the subtraction, the slope formula, and the LP turned out to also be negative 1/2. So those also had the same slope, and that means that MN is parallel to LP. So right now I know that I have a parallelogram. That's already clear because the opposite sides are parallel. Now I could, if I had only had one pair of sides that were parallel, then I could have said it was a trapezoid. Okay, so you have to keep in mind that chart that we just showed. It's in your book, and it will help you come up with the more precise names. All right, so I know that it's a parallelogram, but there are some figures that it could be that are special cases of that. So I would want to check and see. It doesn't look like a square or rectangle, but it could be a rhombus. So I'd want to check and see if the sides were equal, and I would use a distance formula to do that. So I calculated each of the lengths of the sides by using a distance formula. I found LM, MN, NP, and LP. They all turned out to be the square root of 5. So each of those sides has the same length, which means, okay, it's a parallelogram with the same length sides but no perpendicular sides, so its most precise name would be a rhombus. Okay, so in this section you're going to do a lot of these kind of problems where you're using the slope or the distance formula. So just kind of get used to that and look out for when you can use those. All right, so quick check 2 asks us to determine the most precise name for ABCD, and they've given us the vertices. So let's put those on the graph. Negative 3, 3 would be here. 2, 4. There's my B. 3, negative 1. And negative 2, negative 2. So there's my D. Okay, so to me this looks like it could be a rhombus, maybe a square. So we're going to check our slopes again. I'll check the slope of AB first. I'm going to change colors and see if that helps my pen work better. Alright, so I'm going to be subtracting the y values on top, so 4 minus 3 over 2 minus a negative 3. So it's going to be a 1 on top over 2 plus 3 is 5. So 1/5 is the slope of AB, and I'm just using these points that they've given me up here as I'm calculating it. Alright, I'm going to check CD next because that's the one opposite AB. So that would be negative 2 minus a negative 1 over negative 2 minus 3. So I'm going to get, it becomes plus, I'm going to get negative 1 on top over negative 5, which is positive 1/5. Okay, so I know that because these slopes are equal, I know that AB, that line is parallel to the line CD. Alright, now I'll calculate the other slope. So I'm going to work on BC and AD. Alright, so for AD it would be negative 2 minus negative 2 minus 3 over negative 2 minus a negative 3. So that on top is going to be negative 5. In the denominator I'm going to get a positive 1. So the slope of AD is negative 5. Okay, so for this one I'm going to have 4 minus a negative 1 over 2 minus 3. That's going to give me a positive 5 on top over a negative 1 on the bottom, so that would be negative 5. It looks like I wrote a 3. Okay, so these two have the same slope also, which means AD is parallel to BC. Okay, now another thing that I could look at is how do the slopes of AB and BC compare? So if I look at AB here and BC here, they are negative reciprocals of each other. So what ends up happening is all of these end up being right angles in the corners because the adjacent slopes are negative reciprocals of each other. So this means it's at least a rectangle. It's possibly going to be a square. So I would need to check the distance. So for AB, that will be 4 minus 3 squared. You're always subtracting the x-coordinates and squaring them plus the y-coordinates subtracted. Oops, I did it backwards. It won't really matter. 2 minus a negative 3. Since I'm adding, the order doesn't matter too much. This is going to end up being, let's see, 1 squared is 1. This is 2 plus 3 is 5, and that squared is 25. So I end up with the square root of 26. All right, and then I would check the next thing. Check BC. So this would be 3 minus 2 squared plus negative 1 minus 4 squared. Right, that's going to end up giving me 3 minus 2 is 1 squared is 1, plus a negative 5 squared is 25, which is a square root of 26. So those are the same. If you continue to work these out, you would end up with CD would end up being also the same thing. And AD would also be square root of 26. So this figure is not just a rectangle or a parallelogram. The most precise name would be a square. Okay, now one more kind of example so that you can see other things you might do. They may give you a picture and tell you that what kind of figure it is and then ask you to find a variable. So in example 3, JTKB is a kite, and they're asking me to find the values of the variable. Now I have X's on most things, but on this one it's a Y, so I'm going to use it last. But remember, with the kite, the top two adjacent sides are equal, and so are the bottom two. So I'll start with the bottom two and say 2x plus 4 equals 3x minus 5. And then I would solve that equation. So I would end up with x equals 9. And then I can use the top and two sides and say 2y plus 5 equals x plus 6, but I can put in that 9 for the x. So 2y plus 5 equals 15. Which leaves me with 2y equals 10 and y equals 5. So my two variables are y equals 5 and x equals 9. Okay, pause this and try quick check 3. This time you're given a rhombus. Okay, so I hope you gave yourself a chance to work that out. Now, what we know about the rhombus is that all the sides are the same length. So I can set equal the ones that have the same variables. I can say 3b plus 2 equals 4b minus 2. That's going to end up giving me b equals 4. And then I can use 5a plus 4 equals 3a plus 8. All right, that's going to give me 2a equals 4, so a equals 2. All right, now this is part of what they asked for, but then they wanted us to find the length of the side. So if I put 4 back in for b, then I could do 4 times 4 is 16 minus 2 is 14 for the side ST. On top, 3 times 4 is 12 plus 2 is 14 for LN. These should all end up being 14, but it's good to double check. All right, I'm putting in 2 for A, so for LS I'll have 5 times 2 is 10 plus 4 is 14. And 3 times 2 is 6 plus 8 is 14. So each of the sides is 14. All right, that's it. I'll see you in class.